In binomial distribution, we have discussed how to calculate constant value in binomial distribution, how we can calculate arithmetic mean, how we can calculate standard deviation, etc. Sometimes in binomial distribution, the frequency is given, original frequency is given, and on behalf of the binomial distribution, we calculate the estimated frequency, and with the help of the chi-square test, we can calculate the difference between the original frequency and estimated frequency, whether this is normal or whether it's due to any region the change in the original frequency and estimated frequency is over there. So sometimes this type of the question is also available in our examination, where we have to use two tests. One is binomial theorem we have to use, and other one we have to use the chi-square test is over there. So in today's video we will learn, if original frequency is given and we calculate the estimated frequency, then how we can use the binomial distribution in such kind of the question is over there. So we will having two question related to this original and estimated frequency is over there. The very first question we are having one question which is very important with the relation of the binomial distribution. For a binomial distribution, a student calculate the mean is 5 and the variance is 9. For a binomial distribution, a student calculate the mean value is 5 and variance NPQ is equal to 9. So we are to calculate whether he have calculated is right or not is over there. This is a question 2 times I have seen in the examination, so that's why I am taking this question in this video. A student calculated in binomial distribution, the mean he calculated is 5 and the variance calculated by him, or we can say the standard deviation calculated by him, is 3. So comment on this whether he is right or not. So as we now saw, NP is equal to 5, equation number first, and NPQ is equal to 9, equation number second. So we will write here value of NP. So 5 multiply Q is equal to 9. So the Q is equal to 9 upon 5. So the Q value is 1.4, that is 1.4, and this is wrong. So it means the calculation is wrong, because the value of P plus Q should be 1. If Q value is 1.4, so the P value may be not negative is over there. So we will comment that the student have calculated the wrong calculation is over there, because the value of Q cannot be more than 1 is over there, because the P plus Q value is 1, the probability or not probability is 1. So it is not possible, it means his calculation is wrong. So just we are to comment on this, that whether the student have calculated right or wrong. So we will say the student calculation is wrong. Next question, that is related to question number 2. Okay. Question number 2. 5 coins toss up 320 times. How many coins? 5. In coins, probability of getting head and probability of getting tail is 1/2. So the result for the head, result original is 0 head, 1 head, 2 head, 3 head, 4 head and 5 head. Original frequency is having 80, then 570, then 1100, then 900, then 500, and last one is 50. So the question is saying whether, firstly, what the question is saying, firstly understand the question. What the question is asking: 5 coins toss up to 3200 times. Probability of get is 1/2, probability of get tail is 1/2. So the original frequency, 0 head they get 80 times, 1 head they get 570 times, 2 head they get 1100 times, 3 head they get that 900 times, 4 head they have get in 500 times, and all 5 head they have get in 50 times. So this is the original data. This experiment have repeated up to 3200 times. So here n is equal to 5 and probability of getting 0 head. So we will having 5c 0 p raised to power 0 q raised to power 5, and this repeated n. So 3 to 0 multiply 1 multiply 1 by 2 raised to power 0 multiply 1 by 2 raised to power 5. So that will be 3200 multiply 1 multiply 1 multiply 1 by 3 2. So this will be having 100. So first estimated frequency is 100. Now n is equal to 5. If r is equal to 1, we are to calculate the probability of one head. So formula is n, capital N, NCR, p raised to power r, q raised to power n minus r. That is the formula. So we are having 3200, 5c 1 p raised to power 1, q raised to power 4. So 3200 multiply 5 upon 1 multiply 1 by 2 raised to power 1 and 1 by 2 raised to power 4. So 3200 multiply 5 multiply 1 by 32, because 1 by 2 and 1 by 2 raised to power 4. So it converted to 1 by 2 raised to power 5, and this is 1 by 32. So we will having, that is 500. So estimated frequency here is 500. So we have calculated two estimated frequency, one for the 0 head, second one for the 1 head. Similarly, we will calculate the estimated frequency of the remaining of the items. We will calculate. So here third one is n is equal to 5 and r is equal to 2. So n is 5, r is 2. So capital N, small NCR, p raised to power r, q raised to power n minus r. This is the formula. So here capital N is 3200, 5c2, 2 times 5c2, p raised to power 2, q raised to power 3. So there will be 3200 multiply 5 multiply 4, 1 multiply 2, 1 by 2 raised to power 3, 2 and 1 by 2 raised to power 3. So that will be 3200 multiply 10 multiply, this is 1 by 2 raised to power 5. So it will be 1 upon 32. So there will be 1000. So this is 1000. Now n is equal to 5, getting 3 head. So 3200 multiply 5c3 p raised to power 3 q raised to power 2. So 3200 multiply 5 multiply 4 upon 1 multiply 2, 1 by 2 raised to power 3 and 1 by 2 raised to power 2. So there will be 3200 multiply 10, here also 10, multiply 1 by 32. So there is also 1000. So this is also 1000. Now n is equal to 5, r is equal to 4. So so this will be 3200 multiply 5c4 p raised to power 4 q raised to power 1. So 3200 multiply 5 by 1 multiply 1 by 2 raised to power 4 and 1 by 2 raised to power 1. So 3200 multiply 5 multiply 1 by 32. So this will be 500. So this is 500. Okay. And last one, all 5 head is over there. So this is, we have calculated 5 coin is over there. We have calculated for the probability of 0 head, estimated frequency, then probability of 1 head. Then this is probability of 2 head, estimated frequency is 1000. Probability of getting 3 head, the estimated frequency is 1000. Probability of getting 4 head, the estimated frequency is 500. Next one, estimated frequency for the 5 head. So estimated frequency of the 500 will be also 100, because here you see 100, 500, 1000, then 1000, then 500, then repeat to 100. So n is equal to 5 and r is equal to also 5. So 5c, 5p raised to power 5, q raised to power 0. So that, okay. And this repeated to 3 to n is equal to 5 and r is equal to 5. So 3200. So 3200 multiply 1 by 2 raised to power 5, 1 by 2 raised to power 0. So 1 multiply 1 by 32 multiply 1, because 1 by 2 raised to power 0 value will be 1. So power is 0, so value will be 1. So this cut 100 times, so it will be having 100. So this is estimated frequency. So we have calculated the original frequency of the coin is 80 times getting 0 head, 570 times getting 1 head, 1100 times getting 2 head, 900 times getting 3 head, 500 times getting 4 head, and 50 times getting all 5 head is over there. And the estimated frequency for the same is this 100, 500, 1000, 1500. So we are having original minus estimated frequency. So we are having minus 20, minus 70, plus 1000, minus 100, 0. Okay, original minus estimated. So minus 220, original minus estimated, that is plus 70, that is plus 100, that is minus 100, that is 0, and that is minus 50. So this is 0. Now original minus estimated square, and chi-square test is original minus estimated square divided by estimated, that is chi-square test. So we will having firstly square of this, that is 400, 4900, 10,000, then 10,000, then 0, then 2500. What we have done? Square of 20, that is 400, 70 square, that is 4900, 100 square, that is 10,000, 100 square, that is 10,000, 0 square, that is 0, and 50 square, that is 2500. Now come to the point. 400 divided by 80. Original minus estimated divided by the formula for the frequency getting estimated, that is original minus estimated divided by estimated. Okay, so we will having 400 divided by 100, that is 4. What? 400 divided by 100. So first one is 4. 4900, 4900 divided by 500. So that is 9.8. First one is 4. Second one is 9.8. 10,000 divided by 1000, that is 10. 10,000 divided by 1000, that is also 10. So there will be 20. Now this is 0. 2500 divided by 100, that is 25. So 25 will add to this. So this will be 58.8 we are having. So the value of 58.8. So the chi-square test is 58.8. Value of chi-square. Now we will calculate whether the coin is biased or not. If this is the original frequency, this is the estimated frequency, we are seeing the difference between this. So value of chi-square is 58.8, and degree of freedom on 5% level we are having n minus 1, that is having 1, 2, 3, 4, 5, 6. 6 minus 1. So 5 on 5 we have to see the table value in chi-square test. We will see table value, that is 11.05. So here you will see at the 5% degree of freedom. So value, that is 11.7. I have seen, that is 11.70, 11.07. So table value, it means there should be 11.07, but the value is here. So the calculated value is greater than table value. Because 58.8 is greater than 11.07, it means H0 is rejected. It means so the difference in this difference, yeah, here the difference is 20, here the difference is 70, here the difference is 100, 0. So it means the coin is not all five coin is over there. So something is different in the coin is over there. So the result is different. If H0 is selected, it means there is a no difference in original frequency and estimated frequency, but we are seeing that there is a huge difference is over there. So null hypothesis is rejected. It means the coin which is tossing by the man have some problem is over there. That's why they are getting this type of result. The result should be nearby. If coins are normal coin, then the result should be nearby to the frequency estimated, but the original frequency is so much a difference. It means something is there is a problem in the coinage over there. So we can calculate whether there is a difference between the original data or estimated data, or whether there is no difference between the original or estimated data. With the help of the binomial distribution also we can calculate. So we are having in this manner we can calculate with the help of the chi-square test we can calculate whether there is a due to some region. It means the coin have some region, so that's why in this coin something is different and he is getting more head or more tail, it may be. Okay, one more question related to this we will having 192 families over there, and each family have 4 members. Okay, in 192 family where the chance of an albino child being is 0.25, albino child probability is 0.25. So the probability is 1 by 4 and Q is equal to 3 by 4. Albino child probability. Original data is saying 0 albino child, 1, 2, 3 and all 4. So original data is saying 77, 90, 20, 5. Okay. Total number of child is 3. Okay. Firstly, listen this question. Firstly, listen the question. In 192 families observed, each family have 3 members, 3 childs. The probability of having a albino child, it means a Surajmukhi child, as you see, sir, everything is white in that child. We are saying that is a Surajmukhi child. So the probability of getting albino child is 1 by 4 or not getting albino child is 3 by 4. 192 families have discussed. 77 family have 0 albino child, 90 family have 1 albino child, 20 family have 2 albino child, and 5 family have all 3 albino child. So on behalf of the binomial distribution, calculate the estimated frequency and use with the help of the chi-square test whether it is normal or not. So firstly we will calculate estimated frequency. So here keep it NCR P raised to power R Q raised to power N minus R. This is Bernoulli theorem used. So N is equal to 3, R is equal to 0. So 192, 3C0, P raised to power 0, Q raised to power 3. So 192 multiply 1 by 4 raised to power 0, 3 by 4 raised to power 3. So 192 multiply 1 upon 64. So the first frequency will be 192 multiply 27 divided by 64. So that will first one will be 81. So the estimated frequency is 81. Now n is equal to 0. Having one albino child, so 192, 3C1 p raised to power 1 q raised to power 2. So 192 multiply 3 upon 1. 1 by 4 raised to power 1, 3 by 4 raised to power 2. Okay. So this will be 192 multiply 3 multiply 1 by 4 multiply 9 by 16. So we will having 192 multiply by 3 multiply by 9 divided by 64. So that will also 81. So second value is also 81. Now n is equal to 3, r is equal to 2. So 192, 3C2, p raised to power 2, q raised to power 1. So 192 multiply 3 upon 1, 1 by 4 raised to power 2, 3 by 4 raised to power 1. So 192 multiply by 3, multiply by 1 by 16, multiply by 3 by 4. So this will be 192 multiply 3 divided by 64. So that is 27. So the frequency of this is 27, and last one 3, and r is equal to also 3. So 192 3C3 p raised to power 3 q raised to power 0. So 192 multiply 3C3, that is 1. Multiply 1 by 4 raised to power 3 and 3 by 4 raised to power 0. So 192 multiply 1 upon 64 multiply 1. So this value will be 3. So we have calculated the estimated frequency. Estimated frequency for the 0 albino child is 81. For having 1 albino child is 81. For having 2 albino child is 27. For having all 3 albino child is 3. So this is the original frequency and this is estimated frequency. On the behalf of this, we can calculate the chi-square test. So it's very easy to calculate chi-square test. Already we have calculate chi-square test in one question. Now original minus estimated frequency, that is minus 4, that is original minus estimated. 77 minus 81, that is minus 4, that is plus 9, that is minus 7, that is plus 2. So this value will be 0. Original minus estimated square, that is 16, that is 81, that is 49, and that is 4. And chi-square test, that is f0 minus fe raised to power 2 divided by estimated frequency. So the first one will be 16 divided by 81. So this will be 0.1975. Second one 81 divided by 81. So that will be 1.00. Second one is 1.00. 49 divided by 27. 1.8148. 1.8148. 4 divided by 3. 1.33. So the value of chi-square he will be 4.3456. 4.3456. Okay. So with the help of the original or estimated frequency, we have calculated the value of chi-square test. So the value of chi-square test is 4.3456. Degree of freedom, that is n minus 1, that is 1, 2, 3, 4. 4 minus 1, that is 3. 4, 3. 5% difference level. Table value. On 5% differentiation value, we will see the table value is 7.815. 7.815. Here table value is greater than calculated value. 7.815 is greater than 4.3456. So we will say H0 is truth. So we will say there is the data, original data and estimated data, there is no difference in the original data and estimated data. It means the data is not biased. This is the original data. There is no biasness in the data is over there. In previous question, we were saying that the H0 was rejected. It means the original data have some discrepancies over there. But in this question, the original data is 77, 90, 20 and 5. The estimated data is 81, 81, 27 is 3. So we have calculated the chi-square test between the original data and estimated data, and we found the H0 is truth. It show that data is not biased and this is original data. No manipulation with the data is over there. So I think with the help of this video, you may be learn how to calculate chi-square test with the help of the binomial distribution. Thank you very much.